Hi, hybrid. Here's the warm up for today. Go ahead and pause and see if you can solve these two on the board. Okay, so let's take a look at these. For a geometric sequence with a sub 1 equals 3 and a common ratio of r is 1.25, James writes that equation. What is the mistake that he made? Well, let's write it the correct way first. So if you're looking at the correct way, we know according to the geometric sequence formula, we have a sub n, and then we have our first term. They told us our first term was 3 times our common ratio, 1.25 to the n minus 1 power. So if you look at what they did and what we did, it looks like the 3 and the 1.25 are reversed. So they have the common ratio where the first term should go, and they have the first term where the common ratio should go. All right, and then the second two, we have two sequences. We have to tell, are they geometric? And if they are, we have to tell what the common ratio is. So looking at the first one, I can tell that it's decreasing. So if it is a geometric sequence, it's going to be by a fraction. And if we do the trick that I taught you yesterday in class, you take the second term divided by the first term. So 6 divided by 30, I get 0.2, which is also the same thing as 1/5. And then if I do 1.2 divided by 6, I also get 0.2 or 1/5 and so on, and I can test it out. So this one is, yes, it is geometric, and the R value is 1/5 or 0.2. Okay, and you can double check. 1.2 times 0.2 is 0.24 and so on. All right, let's do the trick for the next one. 2 divided by 0.5 gives me 4. 8 divided by 2 gives me 4. 32 divided by 8 gives me 4. So you can see there is a pattern. Yes, it's geometric. And what did I say that was? Oh, r equals 4. That's geometric sequence. All right, so in today's lesson, we're going to do quite a few things. Let me give you a recap of what we are going to do. I'm going to skip this spiral review just for the sake of time. But if you're looking up here on the board, we have our learning objectives. We are going to do some guided notes for transformations of exponential functions. These should be very, very easy because they're very similar to the absolute value functions. Then we're going to do a quick review, and then we're going to complete formative 2 today. So you need to get this done with yourself, giving yourself at least 20 minutes at the end for the formative. So it is Wednesday, so you guys have this class until 2:55. So I would aim to get your review done by, let's say 2:35-ish. Okay, so aim for maybe 2:30, and that will make sure that you have plenty of time to get the formative done. The formative is only 5 questions, but if you complete today's section and the review, you should have no problem completing that formative. If worst case it comes to where you guys are working the whole time and you need some time tomorrow, Miss P is in tomorrow and she might be able to let you start off with your formative and give you some time for that. Just make sure that the formatives do not go home. They have to stay here. All right, so let's get into it. So you have your notes for transformations of exponential functions. So you see the equation is right here on the left-hand side under transformations of exponential functions. We have the h is up in the exponent touching the x, and the k is at the end by itself. It's very similar to when we had the absolute value functions, just instead of the x and h being inside the absolute value bars, they're up in the exponent. H is the horizontal shift. Okay, so that controls left and right. And I believe I put on your notes, remember H is the opposite. So when you are adding to the X value, you're really moving to the left. And when you're subtracting, you're moving to the right. K is our vertical shift. Okay, and that one's very self-explanatory. Shifting up is when you add at the end, and shifting down is when you subtract. If A is negative, that is going to reflect our function across the x-axis. Okay. If you take a look at the next bullet, the absolute value of A, because we're not talking about the negative, because negative is something different. The A value itself, if it's greater than 1, that is a vertical stretch. So that's going to take our hockey stick type of graph and it's going to make it tall and skinny. And if our absolute value of A is in between 0 and 1, okay, so it's a decimal or a fraction that's in between there, it's going to be a vertical compression. That's going to make it shorter and fatter. Okay, so in the next section, we are going to identify what is the parent function and describe the transformations. This is important because the base of the exponent does not really, it's part of the parent function. It's not going to be part of the transformation. You'll see what I mean once we get into this. So part A for each one, we're going to identify the parent function. So looking at this, what is the part that's affected by the exponent? That's f of x equals 3 to the x. That's what the original in this one looks like. Now B is how did it transform? Okay. Well, if you look at the difference between the parent function and the one above, the only new piece is this plus 5. Okay. That is in our K position at the end by itself. So that's vertical shift. It went up 5. Okay, if you're looking at number 2, the part that is affected by the parent function or affected by the exponent is the 1/4. That's my base to the x power. The parent function will always be a base and an exponent of x. All right, so for what transformed, I noticed there are 2 things that happen to this. I've got a 2 in the front and I've got a -1 up here in the exponent. So those are my 2 transformations. Okay, the A value is 2, is greater than 1. So that is a stretch by 2. And the X -1, that's a horizontal shift. When we're subtracting 1, we're actually moving right 1. Opposite of what you think it is. Go ahead and pause the video and see if you guys can try 3 and 4. Okay, so looking at number 3, the parent function should have been f of x is 4/3. And I like to put the fractions in parentheses. I probably should have done that up here with this one too. Just for, so that way the calculator understands it's fractions. And to the x power. Okay, this one had 3 things happen to it. We've got a negative, we've got a +2, and we've got a +7. Okay, so as far as transformations goes, the negative reflects over the x. X-axis. The +2 moves it left 2. And the +7 moves it up 7. All right, for number 4, our parent function is f of x equals 5 to the x power, the base and the exponent. Our transformations, this one had a few things happen to it. I see a 1/2 in the front. I see a -4 and a -2. Okay, so that 1/2 is a compression or compress by 1/2. Okay, our -4 is going to move it, sorry, right 4. And the -2 is down 2. All right, let's look at the next part. So this one, they want us to graph this function and identify its key characteristics. I find extremely helpful to use an XY table. So I would draw one of those, and we're going to work smarter, not harder. We're going to use our calculators to help us with this. So I'm going to go ahead and pull up my graphing calculator. And I will also show you in a minute what this looks like on Desmos as well. So my graphing calculator, let's see if I can bring it across the screen for you. All right, if I go into y equals, here is my formula right here. I said 2 to the x plus 5. And remember, to get up in the exponent, you need to use the caret button, which is underneath the clear. And it will put it up there. Make sure that the plus 5 is in the exponent. If it is not, it's not going to graph the right thing for you. And I'm going to look at the table. So I'm going to hit second graph to get to my table. Now I see some of my values here are very, very large, and I'm not going to be able to graph them on the graph that I provided. So I'm going to slide up a little bit so I get some more reasonable numbers. So I would probably graph something in this range here. So I'm going to take the ones that I see in this table, and I'm now going to bring them over here and copy them down. So we had -5, 1. We had -4, whoops, -4. -4, 2. -3, 4. -2, 8. -1, 16. And then I'm going to write this one down. We're probably not going to be able to graph it, 0, 32, but let's go ahead and try. Okay, so our idea for this one is we may not fit all of the things on here, but we're going to try to get as many of them as we can. So if I look at this, I can definitely do -5, 1. Okay, I can do -4, 2. I can do -3, 4. And -2, 8 is up here. That's probably all I can fit on here. And I know that this is going to have an asymptote. If I go back to my calculator and back to my graph, if I keep on scrolling up, you'll notice it's going to get really close to 0, but it's never going to actually touch 0. So that means that my asymptote is going to be 0. So when I'm drawing this, I'm going to kind of have it like horizontal to the the y-axis or x-axis and go up like that. All right, so now I have to answer questions. Domain. I can see that it's going to go left forever. It's going to go up and right forever. So the domain, all my available x's are all real numbers. My range are going to be all my y values, but I don't have anything down the bottom. So these are going to be the y values that are greater than 0. Okay, that should be your asymptote. So whatever number you get for your asymptote, that's going to be your range. It's where it bottoms out. All right, end behavior as x approaches infinity. And if you guys remember from when we did this the other day, we have negative infinity on the x and we have positive infinity on the x. So as x moves to the right towards the positive infinity side, it looks like my graph is going up to infinity. And then as my graph is moving to the left towards negative infinity, that graph's going to get closer and closer to 0. Again, you'll see that the asymptote appears a couple different times. Okay, that in the same number. Y-intercept, you can't see it on the graph, but we can look at the table when x is 0, my y is 32. So that is my y-intercept. And then we talked about this, the asymptote, the equation is y equals 0, because that is this vertical line right here that it's never going to actually touch. Okay. All right, let's do one more together and I'll have you guys try one on your own. So in this one, same thing. This time I'm going to use Desmos. Let me bring Desmos over. And it's 1/3 to the x power minus 2. So I'm going to type that in on Desmos. You could also do this on your graphing calculator, but I just wanted to show you how we do this on here. So I'm going to put the fraction in parentheses, 1 divided by 3. It automatically makes it a fraction for me. And then I'm going to use my caret button, which is above my 6. And if we look at the equation, it said x minus 2. Now it automatically dropped it down out of the exponent. Let's say if I wanted it to stay up in the exponent, I'm going to do it on a separate line so you can see. 1 divided by 3. Let's say there was a horizontal change. I would say raised to the, I would have to put in parentheses, x minus 2. That's how you get it to stay up here in the exponent. But this was not a horizontal shift. It was actually a vertical shift. So I'm going to go ahead and get rid of that red one. Okay. We know that it took our function and it shifted it down 2 units, and I can see that on the graph. Now, if I want to see the table, I'm going to go to this gear here and I'm going to click on the table option. Now, Desmos will automatically pick some numbers for me. These may not be necessarily be the best numbers. Okay. Because if you notice it, the highest it goes is -2 and to 2. If I want, let's say I wanted -3, I have to go on here and type in -3, and then it would give me those values. Or if there's any other values that I want, I would have to manually type them in. Whereas on your graphing calculator, you can get to the table and scroll up and down. It's a little bit easier on the graphing calculator. So let me go ahead and copy over our table. Okay, I did go from -3 down to 2. And you can choose however you want. You just want to make sure you have a good picture of your graph because I want to see actual points. I don't want to see just the general shape. Okay, so when x is -3, we had 25, we had 7, 1, -1, -1.6 repeating, and -1.8 repeating. Now, again, we may not be able to graph all of these, but we're going to try to graph the ones we can. -325, not possible, but -27 is. So that's right there. All right, -1, 1, 0, -1, 1, -1.6. So it's like a little bit more than half, and 2, a little bit more than that. So you guys can see it's going to be horizontal here, and then it's going to curve up. Okay, as long as it's kind of the best you can. It's going to look something like that. Okay, so remember in our original parent function, the y-intercept was 0, 1, and this has been shifted down to, and that's why the y-intercept is now sitting at 0, -1. So I'm going to go ahead and add that in there. All right, domain, same thing, going up and to the left and right forever, so it's all real numbers. And our range is going to be all the y's that are greater than our asymptote, which is -2. Okay, and look at this -2 over here. Our vertical shift is a part of that. Okay, so as x approaches infinity, so as x goes to the right, okay, what's happening to our function? It's getting closer and closer to our asymptote, which is -2. As x approaches negative infinity, it's going towards positive infinity. Okay. And our asymptote is y equals -2. All right, go ahead and pause and see if you guys can try number 7. All right, so number 7, if you looked at your table, this time for me, I went from -2 to 3. All right, here are my values. There were some repeating values. There can be some decimals. We're going to try to eyeball this the best we can. Okay, so as far as my graph goes, there's only a few that I can really graph. I can graph -1, 1.6. That's like a little bit more than 1. Then we have our y-intercept at 1.5. And then it goes a little bit more than that. For 1, it goes to 2.5. 2 goes to 5.5. 1, 2, 3, 4, 5.5. And then the rest is all too much. So we're going to have something like this, like that. Okay, domain, all real numbers. Ranges are the y's that are greater than our asymptote, which is 1. Okay, again, look at your vertical shift is 1. As x approaches infinity, our y's are going to infinity. As x approaches negative infinity, we're getting closer to 1. Our y-intercept is 0, 1.5. And the asymptote is y equals 1. Okay. So this is pretty much the transformations. You can use your graphing calculator to help you with that, but you definitely should know what your A, your H, and your K do to your functions. All right, so for the next portion, okay, you're going to complete the topic review on page 255 in your textbooks. So your textbooks are located in the pink bin that says period 7-8. Turn to page 255. There is a note sheet that you can write on. Please do not write in your books. And then there is an answer key provided in the folder. You guys can check your answers. Okay, there are two that you can skip. You will see them on the answer key. It's number 26 and number 27. You can go ahead and skip those, but you should be able to complete all the other ones and check them. All right, when you're ready to start the formative, you guys know the expectations for your formative. Okay, you're showing all work when possible. You can use your calculator. Please demonstrate academic honesty by doing your own work and try your best. Okay, there's no talking, and this should be collected at the end. All your other notes can stay in your notebook. Thank you.